find the dimension of k omega A given in the wave equation, where this is lambda is equal to A sine omega t minus kx, right? This lambda is given in displacement, is the displacement, t is the time, x is the distance. So how do you do that? Dimension of any trigonometry equation is again dimensionless, right? So how do you get the value? They have asked, first you find of omega, then you find of k, then you find of a. So what is the value of dimension of omega?
L t to the power minus 1.
What did you say?
T to the power minus 1.
Okay, so how did you get this?
Omega is the angular frequency.
Yeah, omega is the angular frequency. So, you know what is this? Omega t minus kx. You can say this omega t and minus kx. These both are in angle, right? And angle is always dimensionless. So dimension of, you can say the dimension of omega t is equal to m0, L0, T0. It is dimensionless, right? So now we can find the dimension of omega. Omega times t is equal to n0, L0, T0. So you got omega is equal to t to the power minus 1, m0, L0. Similarly, you can find of this also. What you will get the value of k?
L to the power minus 1.
Yeah. Kx is again m0, L0, T0. And what is x? X is the length, right? So you got now k is, you have got m0, L to the power minus 1, T to the power 0. Now what about the a?
A will be L.
L. Why is it L?
Because the sine term will be dimensionless, so L
Yes.
is equal.
It is a trigonometric function, sine of any angle that is dimensionless. So you get the value of a as equal to L. So we have done with this. Now the 9th one. So you have to verify whether this equation is right. The relation t is equal to. Yes?
It may be right.
It may be right. So how do you do that? You have to check
The
it.
dimension is correct, but we don't know if the coefficient is right.
Yeah. But if, let us suppose 2 pi, no, what is the dimension on the left hand side?
T.
T. Okay. And what will be the dimension on the right hand side?
T.
T. So left hand side dimension is equal to right hand side, right? So we can say dimensionally it is correct, right? Okay. Now the 10th one. So you have to check whether the equation is correct. So that is R G rho. So rho is not visible. So it is rho is the density upon 2s cos theta.
It's not. It is not correct.
Yeah. So how did you do that?
The LHS term dimension is L, and on
Yes.
RHS dimension is L to the power minus 1.
Yes. So you have done it right. So the equation was H is equal to R rho G upon 2s cos theta, right? So the dimension of, in the left hand side, the dimension of H So that is L. Now you're on the right hand side. What will be the dimension? So you can calculate radius R, length, then rho. Rho is what? Density.
ML.
Yeah, mass upon volume, right? Then next one, L, T to the power, right? So that divided by 2 times S. Now what is this S? This is surface tension. So the unit was given. So using that unit also you can write MLT to the power minus 2L, right? And cos theta. What will be the of this one? Cos theta? Yeah. So finally when you simplify this, you can check it out. This gets cancelled. Yeah, one gets cancelled from here. This also gets cancelled. So okay. So okay.
M and T also.
Yeah, M and T also gets cancelled. So finally what is left?
L to the power minus 1.
Okay, so this 2 we no need to write that. So this was clear, okay? Usually the student gets confused when they see the trigonometry function. So always remember the trigonometry function, it is dimensionless and about also the constant. No need to write about this constant, right? So okay, fine, we have got this. Next, let's proceed to the next one, the last one. If force F, velocity V, and time T are fundamental quantities, you have to find the dimension of energy E in terms of force and velocity and time. So that is the third application. We have to find the expression, right?
F V T to the power 2.
F to the power
1.
1, V to the power
1.
Okay, T to the power
2.
Okay, is it 2 or is it 1? Just check it out. So there is some calculation mistake. So K, F, X, V, Y, T, Z.
Okay, it will be 1.
So where did you did the mistake?
I accidentally wrote the dimension of velocity as L T to the power minus 2.
Okay. So force is M L T to the power minus 2. That power X, right? And we have that velocity also, right? What is the velocity expression? L T to the power minus 1. So that's V. Now T to the power Z, right? So you have to substitute the powers of the right hand side equal to the left hand side. So now the powers of M is what?
X.
So M is X in the right hand side and the left hand side it's 1. So we get the value of X is equal to 1. Now if you see with the powers of L, right? In the left hand side it is 2, right? And what about the right hand side? It is X plus Y, right? So what do you get? You know the value of X, you can calculate the value of Y, so Y becomes 1. Now with the powers of T, right? So what you're getting, minus 2 on the left hand side, and in the right hand side it is minus 2 minus 1 and z. So when you solve this, you will get 1.
1.
So f power 1, v power 1, t power 1, right? So, such problems they are asking, they will give you an options, right? 4 options, you have to check which one is right, and then